Hi everyone, so my project consists of 3 parts. First is building this 3D printed joystick. Second is integrating the outputs of the joystick into the RCAM model. And third is getting the RCAM model to spit out the required data to a flight simulation package so that we can fly the plane with the joystick. So I didn't want to go through the process of designing the joystick completely from scratch. Instead, I found this thingiverse project. He includes a bill of materials, some Arduino code written in C, and also any of the 3D models you might need. Now, here is my particular bill of materials in table format. Feel free to pause the video if you want to take a look. Building the actual joystick was difficult for a number of reasons, one being that my Ender 3 3D printer is secondhand, which could have caused a lot of different things, but one of them was my parts were warping on the bed, so in the end, I ended up needing to use a power drill to kind of convince the parts to be the right shape. One of the first parts to build was this inner hinge with the ball bearings, and this is for the pitch axis. You can also see the first Hall effect sensor here. One of the reasons I chose this joystick was because it incorporated Hall effect sensors. Hall effect sensors are made up of an inductive sensor in combination with 2 magnets whose poles oppose one another. With one magnet alone, the magnetic field is very nonlinear. However, when we combine 2, the magnetic field in between the opposing poles becomes linear. This allows us to sense the magnetic field flux using Faraday's law. Moving on, we just need to add springs, the roll axis, and the grip. Next, I added potentiometers and hooked up all the sensors to the Arduino through a breadboard. The breadboard was necessary because there's only one power pin coming out of this Arduino and lots of sensors. Next, I downloaded the joystick library, edited the Arduino sketches necessary, and uploaded the sketch. Any gains on signals can probably be edited more easily in Simulink than in the Arduino sketch. Finally, I needed to calibrate the joystick. It was much easier to use Microsoft's joystick calibration tool than to set the trim points in the C code in the Arduino sketch. Now on to Simulink. Here you can see my overall model, which gets the joystick inputs through the RCAM model, and then through some navigation equations and geodetic position calculations, and then into flight gear. I won't go through everything in detail, I just want to show a couple curiosities and then a demonstration. To get my joystick to work, it was actually pretty straightforward. I just needed to select the correct joystick ID and then fiddle with these gains until I got the outputs in the controls that I was looking for. The RCAM model is basically the same as the one that was defined in class. I made the navigation equations following Chris's lecture. Same with the geodetic position calculations. And now finally, I just need to run my batch file and then start the Simulink model. Here I'm flying without any trim, so I basically start in a free fall stalling and then have to pull out of the dive. Thank you for watching.